Hey, y'all, welcome back. Tonight we're working with the first derivative test. And what the first derivative test does is it gives us a tool to help us use the derivative to find information about the original function. Specifically, it helps us find where the graph is increasing or decreasing and where the graph of the original function has local extrema. So number one says find and classify all the critical points. And we're gonna find those critical points. We're gonna create a sign chart, and we'll use that sign chart in conjunction with the first derivative test to determine whether or not they're max or mins. So first, we'll find the derivative, and we're looking for all the x values where the slope is 0, or where the line tangent to the curve is horizontal. So the derivative is going to be 6x squared minus, let's say 9 times 2 is going to be 18, x minus 24. Let's go ahead and set this equal to 0. That's where we're going to find the critical points. And this quadratic can be a little tricky to solve because that leading coefficient is not 6, but luckily we can divide everything by 6 and simplify this whole thing. So if I divide everything by 6, I'm going to get x squared minus 3x minus 8. Oh, no, minus 4, sorry. Now this is factorable. We can rewrite this as x minus 4 times x plus 1, and that gives us two critical values, one at 4 and one at negative 1. So these are the only points where the sign of the derivative can change. So I'm going to label negative 1 and 4 on this little number line. This number line, by the way, is dealing with f prime, not f. And we're going to test values in each of these intervals to determine whether or not the function is increasing or decreasing on these intervals. And if we can see a change in sign, we know we have either a max or min. We'll cross that bridge when we get there. So first, I'm going to choose a number. I might choose something like negative 3, something that's in this interval from negative infinity to negative 1. And if I substitute that in for x here and here, I can see negative 3 minus 4 is going to be negative 7, and negative 3 plus 1 is going to be negative 2. I really don't care whether, what exactly this thing's going to equal. I only care about whether it's going to be positive or negative. And here we have a negative times a negative, so the derivative is going to be positive in this entire interval. Then we can plug in a number in the next interval. We might choose something like 0, would be easy to compute. And if I plug in 0, I'll have a negative here times a positive, and a negative times a positive is negative. And then to the right of 4, I can pick a number like 10 and substitute that in here, and I'll get a positive times a positive, which is positive. So the original function f is increasing on these outer intervals and decreasing on the interval in between. So if the slope is changing from being positive to being negative, that means we have a local maximum at negative 1. And if the slope changes from being negative to positive, then we know we have a local minimum at 4. So that's going to be how we answer our question here. We have a relative minimum, or I guess we'll start with maximum, at x equals 1, or negative 1. And the reason we're allowed to say that is because f prime went from being positive to negative. That's the justification of that statement. That's how we know. We also have a relative minimum. In this case, it's going to be at x equals 4. And we know that because the derivative, which is the slope of the function f of x, changed from being negative to positive. And the first derivative test tells us that when this happens, when it goes from negative to positive, we have a relative min. So that's how we use the first derivative test. It gives us information about f of x using the first derivative. That's why it's called the first derivative test. So these are our answers. There's really nothing more to it here. We found all the relative extrema. Number 2, for what values of x does the function have a relative minimum? So really all we are looking for is a place on the graph where f prime goes from being negative to being positive. So we're going to set this up the same way as we set up the previous problem. So let's go ahead and do that. First, find the derivative. So f prime will be 6x squared minus 6x minus 12. If we divide everything by 6 here, well, I guess let's set it equal to 0 first, and then divide everything by 6 so we can get the algebra to work out nicely. X squared minus x minus 2. This can be factored as x minus 2 times x plus 1, and so our two critical values are at 2 and negative 1. I'm going to create my sign chart and place negative 1 and 2 on here, and just think about whether these intervals are going to be positive or negative. So if I substitute in a number like negative 3, I'm going to, into each of these two factors, I'm going to get a negative times a negative is positive. Looks like we might have very similar behavior to the last problem. If I plug in 0, I'm going to get a negative times a positive. Negative times a positive is negative. And if I pick a number like 10, I'm going to get a positive times a positive, which is positive. So I can see at 1, I've got a local maximum, and at 2, I have a local minimum. So that's going to be the answer to my question. For what values of x does this have a relative minimum or a local minimum? Those two phrases mean the same thing, local and relative. You can kind of use them interchangeably here. But we have a relative minimum at x equals 2 because the derivative goes from, I guess I'll try to stay consistent with how I'm writing this. You can kind of express it in your own way, but basically what you're trying to communicate is that it's going from being negative to positive. And it's really good to just get in the habit of saying why rather than just answering the question. Number 3 says, let f be a function given by x cubed minus 6x squared. Determine the intervals for which it's decreasing. So we're basically doing the same thing as we did the previous two problems. We're just only reporting back a certain piece of information here. So the derivative of f of x can be found using the power rule, 3x squared minus 12x. So setting that equal to 0. And we can divide everything by 3, make this a little easier. We can factor this out by factoring out an x as a GCF and set each of these equal to 0 to find our critical points. So we get a critical point at x equals 0 and x equals 4. These are going to be the values that I'm going to place on my number line. So if I plug in a number, well, really any negative number here is going to be a negative times another negative is going to be positive. If I plug in a number like 1, I get 1 times negative 3, which will be negative. And if I plug in a number like 10, I'll get a positive times a positive, which is positive. Now, even though it doesn't ask us for the extrema here, I'm just going to give us a bonus, a little piece of bonus information here. We can see that we have a maximum occurring at 0 and a minimum occurring at 4. Okay, so just want to point that out. But this is just asking for which intervals is the function decreasing. And we can see that it's decreasing on the interval 0 to 4. And we know it's on 0 to 4 because the derivative is negative. I'm going to put that little justification on every single answer here. Even if it doesn't ask me to specifically justify my answer, it'll be a good habit to be in so that you don't forget to do it. And also just so that you are comfortable with telling me how you know that what these answers are, what they are. Number 4, now we're being given the actual derivative and not the original function. And so we want to know what's going on at each of these critical points. If we set this equal to 0, I guess I don't need to find the derivative because it already gave it to me. But if I set that derivative equal to 0 and solve it, I'm going to find my critical points pretty easily because this is already factored. So I know my critical values are at 2, 3, and 4. You might have just gathered that based on the statements in the problem. But let's go ahead and create our number line here. So I've got 2, 3, and 4. Now, it says, then f has which of the following relative extrema? So basically we want to know like which of these are true. And so we'll have to decide whether or not we have a max or a min at each of these values. So if I substitute a number in like 0, and I plug that in, I'm going to get a negative times, I'm actually going to ignore this squared factor because that's always going to be positive. And so when I multiply it, it's not really going to affect my final answer here as far as if it's being positive or negative. So let's go back here. If we plug in 0 into this one, if we plug in 0 to this one, it's negative. And if we plug in 0 to this one, it's negative. So again, a negative times a negative is positive. Then if I plug in a number between 2 and 3, like 2.5, this is going to be positive times a negative is negative. And then if I plug in a number between 3 and 4, like 3.5, I'm going to get a positive times a negative again. So this is going to be also negative. Little thing to point out here is that the sign is not changing at 3, and that is connected to the fact that the multiplicity on this root is even. So anytime you have this like squared factor or factor to the 4th power, you should expect the sign chart to reflect the sign not changing. And so we're not going to actually have an extrema at 3. And then after 4, we could pick a number like 10, in which case we'll have a positive times a positive. So the slope is going to be positive here. All right, so let's just break this down. At 2, we're going from a positive slope to a negative slope. Okay, positive slope to a negative slope, that's going to be a maximum. So we can go ahead and say, yeah, that's going to be a true statement. At 3, the graph has a negative slope followed by another negative slope. So actually the graph's going to do something like this. So at this point, it's not going to be a maximum or a minimum. So it's definitely not a minimum. At 4, we have a negative slope followed by a positive slope. So we have a minimum here. It is not a maximum. So 3 is going to be wrong also. So the only true statement here is the first one. Number 5. Ooh, we get to finally, this is the first question all year long that we have been allowed to use a calculator. How great is that? It says a particle is moving along the x-axis so at any time its velocity is given by this velocity equation. What's the acceleration of the particle at time equals 6? Okay, so this is really just kind of a throwback question, and what you have to remember is that the derivative of velocity is acceleration. So we're going to have to differentiate that, and we can do that using both the product rule and we're going to have to use chain rule. So let's find our acceleration function, which again is the derivative of velocity. Using the product rule, if I use this t squared as my f and the natural log of t plus 1, there's my g. The derivative of f times g is f prime, maybe I'll just write it over here, f prime g plus fg prime. So first I need to differentiate t squared, and that's just going to be 2t. Times g, so that's times the natural log of t plus 2, plus f, which is t squared, times the derivative of f, which is 1 over t plus 2 times the derivative of t plus 2, which is actually just 1. So even though we're really supposed to use a chain rule here, the derivative of t plus 2 is 1. We don't have to write that times 1, but I just want to, you to see that, yeah, we did use chain rule. It's just the way it worked out. Okay, this is a function that we need to plug in 6, and this is where the calculator comes in, and this is like the kind of problem that you would see as on the calculator section where, if the numbers worked out nicer, you really don't need a calculator, but in this case, evaluating 2 times the natural log of 2 plus 2. This is not going to be something you would be expected to do mentally. You'd be expected to set it up for sure. But this is something that we're just going to have to type in the calculator. So I might find a way, if I can find a way to embed the calculator here, I might work that out in post, so they say, after I finish recording this video. But at least while I'm recording this video, I just have my calculator out to the side. And I'm going to type this in: 2 times 2 times the natural log of 2 plus 2 plus 2 squared times 1 over 2 plus 2. And I'm getting, let's see here. Oh, I mistyped that. Let me back it up a second. Oh, hold up. I'm not plugging in 2. What am I doing here? Oh my God. Where did that 2 even come from? Let's back that up. This should have been 6. Oh, come on, Mr. Schuler. I know you guys are watching thinking, what are you doing? Let's throw in a 6 there, not a 2. Where did I even get 2 from? Probably wonder. Yeah, I'm sure you guys are wondering what is going on there. Okay, let me try to retype this again. Because, yeah, I got an answer that wasn't any of those choices, and then it tells me something's wrong, and that was it. So let's see here. So 2 times 6 times the natural log of 8 plus 6 squared is 36 times 1/8. There we go. Okay, this looks a lot better. We're going to get 29.453. Okay, now I do have a link here to the Desmos calculator. You don't really need the graphing aspect of this at all. You're really just using those, using it for that natural log function. But if you're comfortable with this Desmos calculator, then you don't really have to bring in a TI-84. And honestly, the TI-84, it has its place, but you're not really going to need it. That Desmos calculator will do anything you need it to do. Number 6, we've got a graph. Oh, okay, here's where it gets a little tricky. We had this before here, where we're given the derivative, but now we're given the derivative graphically. So we don't have the original function. This is a graph of the slope. This is new. Okay, so let's see if we can't really break this graph down. So this is a graph of the derivative. This is f prime. And what I'm going to do here is put these critical values where it's 0, right, at 2 and 4 and 6, and just kind of map the sign of f prime. Okay, I'm not solving an equation. I don't have to plug in any numbers. I just have to look at the graph. So notice between 0 and 2, and I should put 0 here too, because I don't really know what's happening. To the left of that, looks like it just stops there. So put 0, and actually I'll cap it off at 7 also. In that interval between 0 and 2, we see on the graph that the f prime is negative. It's also negative between 4 and 6. So in between 0 and 2 and 4 and 6, the slope of f is negative. I'm being careful with my words here. The slope of f is negative. The value of f prime is negative, and f prime represents the slope. I am not talking about the slope of f prime. Obviously, the slope is changing with these little shaded regions I just highlighted. But it's all we care about is that whether or not it's negative or positive for right now. We can also see that the slope of f, or the value of f prime, is positive when the graph is above the x-axis. So the slope is going to be positive here and here. And just reinterpreting this graph as a sign chart is going to be helpful when we answer some of these questions. So it says, on which of the following intervals is f decreasing? Well, f is decreasing when f prime is negative. So those are going to be along these like red shaded regions between 0 and 2 and 4 and 6, or answer Z. And down here it wants us to justify. It says, I know f is decreasing on these intervals because f prime is negative. Number 7 says, for what value of k will this have a relative maximum at x equals negative 2? All right, so let's see if we cannot find the derivative first. So y prime is going to be the derivative of x is just 1. The derivative of, well, you know what? Let me rewrite this y as x plus k times x to the negative 1. It'll be a little bit easier to differentiate if I write that algebraically. So I've got y prime is 1, and then it would be plus negative 1 times k, so minus k x to the negative 2. All right, so we will have a relative maximum if this goes from being, if the slope goes from being positive to negative. So relative maximum means y prime goes from being positive to negative. Okay, so let's set this equal to 0 and see what's going on here. So I want to know, when is 1 minus k? Oh, actually, I don't even have to do that. Let's back that up. We don't have to make a sign chart here because we just want to know if it's going from positive to negative. So let's find out what is happening, first of all, at x equals negative 2. So if I plug in negative 2 here, I should get 0, right? Negative 2, negative. So that means that, let me back this up. In order for that to even be a maximum, by the way, y prime's got to be 0. So if you have 0 equals 1 minus k times negative 2 to the negative second power, we could solve this for k. And so we've got subtract 1 on both sides, negative 1 equals negative k times 1 over negative 2 squared. So negative 2 squared is going to be 4. If I multiply 4 on both sides, I'm going to get negative 4 equals negative k. So k is 4. Now, here's kind of the tricky thing here. We know k should be 4, but all we know about k at this point is that it's a critical value. So it's potentially a relative maximum, but we don't know for sure if it is. Number 8, it says at x equals 0, which of the following is true about this function? So what we need to do is find the derivative. 2x, it'll actually end up being minus because we're going to have to, actually I'll just go ahead and write plus. Plus e to the negative 2x times the derivative of negative 2x, which would be negative 2. So if I want to know what's happening at 0, so if I plug in 0, you get 2 times 0 plus e to the 0th power. Anything times 0 is going to be 0 times negative 2. So I've got 0 plus 1 times negative 2. So that's going to be negative 2. I don't really care exactly what it equals. All I really care is that it's negative. And since the derivative is negative, when x is 0, f is going to be decreasing. The reason why we know this is true is because f prime is negative. So we can say f is decreasing at x equals 0 because f prime 0 is negative. Number 9. It says when f prime is greater than 0, we know that f is increasing. When f has a maximum, we know the derivative goes from being positive to negative. Just to nail down this definition, a critical value is when the derivative equals 0 or is undefined. Finally, number 10 says, use calculus to determine a formula to find the x value of the vertex of a parabola in this form. Okay, so let's find that vertex. Let's find that point where the slope is changing. Now, you might already know this from Algebra 1, that it's going to be negative b over 2a, but let's use calculus to actually prove that to be true. So y prime would be 2ax plus b, right? And this max or min is going to occur when the derivative is 0. So if we're going to solve for x here, we're going to subtract b and divide by 2a. And look at that. There's our formula. You might have used this back in Algebra 1 to locate the x-coordinate of the vertex, negative b over 2a. That might sound kind of familiar. But we can see, using calculus, that is for sure going to be the case. All right, that about wraps it up for tonight's homework. Y'all, thanks for watching. Please reach out if you have any questions, and I'll see you next time.